I find databases endlessly interesting, and for good reason, right? As programmers, we're always going to need more options for storing and reshaping data. And as that data becomes more important to us over longer timescales, then your choice of database and the behavior of your database can become perhaps your most pivotal design decision. That's why there are so many options. We need so many options. We need everything from the huge enterprise distributed cloud databases all the way down to a relational database so tiny you could find it in your thermostat or your watch. There's definitely a SQL database inside your phone and inside your browser, and it's going to be SQLite. It's the embedder's choice. And SQLite's fantastic. Let's be clear about that. It's small, it's light, it's extremely reliable, it's surprisingly feature-rich. It's a success. But you can always want more, can't you? You can always ask for more. The two features I've found I wanted in the past from SQLite are concurrent writes. That'd be good. Doesn't need to be wildly performant, but writing from multiple threads would be nice. And synchronization. Wouldn't it be great to be able to write to a local database on an iPhone and have the changes magically sync to the cloud once the internet connection comes back? I'd love that. Is there any chance of seeing it in SQLite? Not really. I can't see it happening. The design is pretty much locked down. And while SQLite is open source, it's not really open to new contributors. So, my guest this week has taken the very bold move of rewriting SQLite in Rust. I'm joined by Glauber Costa to explain how you rewrite SQLite, why it makes sense, and why it might be the only realistic way to get an embedded relational database with a whole new wish list of features, like concurrent writes, like CDC, so you can subscribe to a stream of database changes, and like vector indexes for lightweight, local agentic databases. It's ambitious. It's potentially a huge project, but Glauber's not doing it alone. It's easy to point at Rust as being the headline difference from SQLite, but it's the open contribution model that Glauber's most enthusiastic about. So let's take a look at how the community is building a new embeddable database called Turso. One quick note before we begin. When we recorded this, Turso was in alpha. It's now in beta. So congratulations to the team on the progress. And if you hear something in this that you're keen to try out, remember beta is a marker that they want you to try it and send your feedback. Link in the show notes. Let's get started. I'm your host, Chris Jenkins. This is Developer Voices, and today's voice is Glauber Costa. Coming in live from Texas, I believe, Glauber Costa. How are you doing?
I'm doing great, Chris. Thanks for having me.
I'm very pleased to have you here. Where you are is probably as swelteringly hot as it is over here, so I hope the air conditioning noises don't disturb the podcast.
Yeah, it's and the fun thing is that I moved 2 months ago, so I'm relatively new to Texas. I feel at home already. It's a great place. Everybody's very friendly. But I moved two months ago from Canada, where the temperatures are not the same as in here. So I'm looking forward to the winter, and it is very, very hot. I knew this was going to be the case, so I'm not complaining about it. But, it's one of my favorite phrases from The Matrix, if you remember the movie, like knowing the path and walking the path, two different things. So like being being here in the heat, I mean, it's been one of the most challenging parts of the move, but I'm enjoying it so far.
Well, as long as you've got plenty of air conditioning, you can always adapt to anything, right? I believe that's how the whole of Dubai works. The Americans
do very well is, right, just like the AC everywhere.
Yeah. So I've got to somehow bridge from that particular piece of technology through to some more intricate technologies. Looking at your background, we could almost do 2 whole podcasts, and I'm going to get on to the main topic. But you've got to tell me a bit about your background being a Linux kernel contributor, because that's some interesting stuff that I've never looked at.
Yeah. So I contributed to the Linux kernel, of course, in various ways, and sometimes more, sometimes less, sometimes doing more interesting things, sometimes more boring things. But for a grand total of 10 years. So I started by around, I think my first contribution was around 2003, 2004. And then I was very active until around 2013. So nine or 10 years was the total time that I spent at that. It was actually my first introduction to programming, in a sense. I mean, I learned it in school, but I got fascinated, and I could never explain why. It's one of those things that it just happens to you. I could never explain why, but I always got fascinated with the Linux kernel, and I was fascinated with the open source nature of that. I think that the first time I even used Linux was 2000 or end of the year 2000, beginning of 2001. And I will never forget that I was using Windows at the time, as everybody else was.
Yeah.
And then I had this friend in college that said, "Dude, you got to try this. This is going to blow your mind. And the source code is open. You can read the source code." And I still remember that, like, I did not know that you had to download the source code. I was assuming that you install Linux and the source code is just magically there.
Yeah.
So I started looking for it. The first thing I did when I installed Linux the first time, I started looking for the source code, and then I found, and I did not know C at the time. I was in college, so we were learning Pascal, which is it's a language just for learning. At the end of the day, and we're not going to go there, but I don't like this idea of a language for learning. But that's what we had at the time.
Yeah.
So I knew nothing of C. So I start looking. I said, "Where's the source code? I mean, I install Linux now. I want to see the source code." So I find this .h files, which are the header files, and they only have like constant definitions. Although the Linux kernel has a bunch of code in the .h files, but I start reading them and I don't understand anything. But I'm mesmerized. It's like it was like this mystical experience, in which I have no idea what's going on here. But wow, I am reading the source code. Like, am I understanding? Of course not. But I'm reading the source code, and then I went into this. I started learning C. My goal was always like, I want to be able to write code for the Linux kernel. I don't know where this came from. It was just something. And a couple of
Just
years
a flash
later,
from the skies, right?
Yeah, a couple of years later, I actually started understanding. Well, at first I learned that you had to actually download the source code. It wasn't there. There was just the header files. And then I started doing like small things here and there, and just reading books. There was a bunch of very good books at the time about the Linux kernel and the internals, which is something I think not a lot of projects do today. I mean, but at the time, and Linux being, of course, the behemoth that it is, there were many books about like the internals of the Linux kernel. So I read them back to back.
Yeah.
One of them I think was I don't even remember the names of the books, but I think it was Understanding the Linux Kernel, one of them that I read. And circa 2003, 2004, I think I sent my first contribution to the Linux kernel mailing list, which was rejected. And
what was it?
The maintainer,
what was it you were trying to submit?
Say that again?
What was it you were trying to submit?
It was a couple of fixes to the ext2 file system. That's how old it was, because we have ext4 now for a long time. And the maintainer of the ext file systems and the virtual file systems in general, I will never forget his response. He was a very loving. The Linux kernel community is known to be a very loving and nurturing place. So his response was that he has never seen code this bad in his life. I managed to introduce 3 bugs in 2 lines of code, and people like me should never be allowed close to a keyboard again. So that was my introduction to Linux. Yes.
I'm surprised you stuck around after that.
As I said, I was very motivated.
You must have been.
I don't know why, but I could never explain that. But I was very motivated. That was my dream, to land code into the Linux kernel, and then I did, and that became my job. Right, my first job was at Red Hat, and I was at the time in the virtualization group. The virtualization was the AI of the day, like the hot technology.
Yeah. I remember the whole VMware explosion.
Company. Yeah, that was this very interesting company. They were a bookstore. And so you could buy books from them online, called Amazon, and they were using virtualization to try this very crazy project to have like something called the cloud. So they
Yeah.
were all like the new things at the time. Red Hat was a provider at the time for Amazon. And then my career started like working professionally. Of course, I mean in the beginning I was just like this guy who did some cool stuff. But then I had the opportunity through my job at Red Hat to work in many things. I mean, the bulk of it was around virtualization. I later worked in containers, the C groups subsystem, which today underpins the container technologies. So I've done a lot of like very low level x86 code for the boot sequence as part of the
Oh,
virtualization
wow.
work.
Okay.
Yeah,
You've gone all the way down to the chipset.
yeah, memory management, scheduling as well. This is actually why I'm very grateful that I worked in virtualization, because you end up virtualization is essentially this idea that you have the virtual machine running. So there's a Linux on top of Linux, and you end up having to do everything. Right? So there's a how to. You have problems like how to. One of my biggest contributions was in the timekeeping code, because you had those virtual machines that couldn't keep time right? Just in the early days, timekeeping in the Linux kernel was based on interrupts. A interrupt would come, and then you would count how many interrupts you have received, and then every interrupts come every 100 milliseconds. Then you count how many you have received, and then you know how much time has passed. And the
Okay.
hardware is very precise to do this. But the virtualized hardware is absolutely not precise, because the virtual machine might not even be running. So we had a lot of issues around timekeeping. I worked a lot with that, and then like how do we schedule efficiently processes that are in the virtual machine, knowing that the scheduler may or may not. It's another assumption of the Linux kernel that the scheduler will always be running, right? But again, in a virtual machine, that's not the case, because the virtual machine itself may not be running. And then how do you manage memory across virtual machines? And so I ended up working with essentially the entire kernel, right?
Right. Yeah.
Yeah.
You must have known the stack inside out by then, if that's even possible
Uh,
with the Linux kernel.
it's not possible, because there's always something. One of the last things I've done was around networking, and that's around the time I was I think I had the sense of I had enough, and I think that the rudeness and the brutality of the Linux kernel eventually got to me. I'm not ashamed to say. I mean, just at some point I was just tired. I was like, look, man, it's just people screaming at each other, and
Is it?
yeah.
Because I know
But it's not
Linus
just
has a
that, but
reputation for it,
yeah,
but it
yeah.
percolates down to the whole community, do you think?
It's not the whole community. It's not the whole community, but it's a large part of the community. And because I mean, Linus starts becoming a role model, right? So and
Yeah.
then people emulate this behavior. So it's a very common thing to see, like people screaming. And I think I was in need of a new. I was feeling like already like, hey, maybe I want to do something else. I'm not afraid, and I think it's just nice for me to talk about this openly. It might feel depending, say, oh, you didn't stick around. I did for 10 years. I had very thick skin, but I think at some point I just got tired of it, and that was one factor. That was not the factor, but it was one of the factors that led me to go work in other things. Not everybody was like that, mind you. Today I have a co-founder, which is one of my best friends, called Pekka. Pekka at the time was one of the maintainers. I was never a maintainer in the Linux kernel. I never. It's not even about rising to this position. I don't think it's the right term. It just didn't match my personality to be maintaining things. I was more the IC type, in which, hey, I want to
Yeah.
code and want to contribute, and not like the maintainer job is very different.
Yeah.
And Pekka was a tremendously good maintainer. He was one of the maintainers of the memory management subsystem. Memory management in Linux is a large thing, so there were many maintainers dealing with specific parts of the stack. And Pekka was one of them. And we became very good friends at the time. And he was always a very gentle, very nice person. Now, his Finnish, like Linus. So the way a Finnish person is nice is different. So there's some room. There's some room there for some. How can I best put it? Like extreme honesty. But
Yeah.
you can do extreme honesty in many ways, and I think I like the way Pekka does it. Did it at the time and still does it today. Andrew Morton, at the time, he was like the number 2 in the Linux kernel. He was famously a very nice person. Greg as well, which was maintaining a lot of the stable releases. So there were very nice people in the Linux kernel, but this environment of like people fighting was pervasive, right? And Linus, of course, it's just his style. It is what it is. But it
Yeah,
trickles
yeah.
down, I think, to a large part of the community.
Yeah, I can totally understand that. And anyway, 10 years on any one project is a long time, right?
Yeah,
But where do you
yeah,
go after that? I mean, what's meaty enough to sink your teeth into after the Linux kernel?
yeah. So I joined a startup in 2013, and that startup was founded by the creators of the KVM hypervisor. The KVM hypervisor was a hypervisor that I worked with. I mean, hypervisor is a technology that underpins virtualization. So I worked with them. I knew them
Okay.
personally for a very long time, Avi and Dor. And they started a company, and I decided to join them honestly. And again, they know that, so I'm not talking behind their backs or anything like that. I did not believe in the project that they were doing. I didn't think it was a great idea. And maybe it was just an idea that was ahead of its time. It was a unikernel. So a unikernel is a specialized kernel that runs a single process. There's a very good unikernel that is growing a lot today called Unicraft. I chat every now and then with their founder. But at the time, they had a project called OSV, which the idea was like, hey, cloud computing is now a reality, whereas 5 years ago it was just a promise. Now it's a reality.
Yeah.
But we end up in the situation where you have a heavy Linux kernel as the hypervisor running a heavy Linux kernel in as the guest. So can we come up with a new kernel that will only run one process? And this is much lighter. This is way more efficient. I didn't quite believe in that, to be honest, but and they know it.
Do you mean
But
you
I wanted to
didn't
join the
believe
company. I
it?
wanted to join them, right?
Yeah, yeah. Do you mean you didn't believe that it was possible to do well, or you didn't think it was a good business idea?
I didn't think it was a good business idea.
Hmm.
Yeah,
Why
and
not?
and and I also believe that if we were going to do that technically, like the best way to do this was to likely turn Linux into a unikernel, uh,
Oh,
which is a much larger project. But with the constraints of a startup, it's not the kind. It's very hard to do. Now, I had a friend also from the Linux kernel. Most of my friends at the time were working in the kernel, and then I had the friend that told me, "Look, Glauber, Alex was his name," and he said, "Look." I knew very little about startups at the time, so I took his advice. He said, when you have a team of very fascinating, bright people together.
hmm.
If they don't get it right the first time, they get it right the second time, the third time, however many takes it needs. Because I was seeking advice. I mean, look, I would love to join Avi and Dor because I like them, and they're brilliant, and I think I want to work at something small, like and like a startup thing.
Hmm.
I don't know, but I don't quite believe in this. And Alex's advice at the time was, I took it to heart. Said, man, if this is not the thing, I'm sure they will come up with something, and that's exactly what
Right.
happened. Because after 2 years, this project failed, but the company pivoted into a database company. So we ended up
Ah.
writing a database called Scylla, and then I spent another 10 years, almost 10 years with them. So that I like to. I'm of the belief that if you don't spend time, you never actually get to know something deep enough, right? A lot of people today, they just jump from thing to thing,
Yeah.
and I think there's an aspect that, hey, you just need time with something. There is something that time gives you that you can't replace. But it wasn't almost. It was around 8 to 9 years, and it wasn't Scylla because the first 2 years it was the same group of people but doing something else.
Hmm.
But I spent another, let's say, 8 to 9 years in the company. And that was my introduction to databases because we ended up writing a database from scratch. Right. So,
Right. Yeah, yeah. With a team of how many people?
I think we were around 12 people, 12 to 15 people at the time. It was a large team already from
Y-
the start. Right.
Yeah, yeah. It's funny. A database is a sufficiently complex project that you can't do it with a small number of people, but it's a sufficiently intricate project that you can't do it with a large number of people either.
Once it reaches a certain level of velocity, I think you can absolutely do it for a large number of people, but not in the beginning, right? Just I bet that Oracle has a lot of people working on the database, right?
Yep. As I understand it, very few people actually touch the core anymore.
It might very well be, like
Yeah.
especially Oracle, but you use, I think, a word that is critical, the core. Because a database, much like the kernel, is a very complex system. So if you look at the Linux kernel has thousands and thousands of contributors at any given moment. I think I've heard the number 10,000 a while back of active contributors.
Hmm.
If you look at lifetime, it's probably an absurd number.
Yeah.
But there is the core of the Linux kernel, and the Linux kernel has layers. They're all
Yes.
contributing to the Linux kernel, but only very few people are contributing to the core of the Linux kernel, like I did, to the scheduler, to memory management, to networking. So it's a group of people that we all knew each other, and we were all friends because it was a very, very, very small group. But then when you count the number of people working in drivers, working in like attachments to the Linux kernel, then this number grows very much. And I bet that with a database like Oracle, is the same thing. You have this core, like the query engine, but then you have all sorts of things that a database does, right?
Yeah.
That is it's easier to put people working in those places.
Yeah. All the way out to the teams of people just selling rebranded open source projects at
That
consultancy
happens too.
fees. Okay. At the risk of getting ahead of ourselves, I begin to see a picture emerging that brings you to your current project. You've got a taste
That's
for
right.
large open source contribution projects. You've got knowledge of how an operating system can work and not work, if I can hint at that. And you've got a taste for databases.
Mm-hmm.
So where does that leave you when you get to the end of the Scylla project or your involvement in it?
Yeah, so I'll just mention briefly after Scylla, I had a 1 year stint at Datadog, and again, I don't like short stints like that. But first, and I love Datadog. It's one of the most fascinating companies I've seen. They have a lot of very interesting data problems. But by nature, I'm a person who likes to build stuff from the ground up, right? And I think what I always wanted to do after Scylla was to start my own company. But I got to that state, and it's the same malaise that hit me in the Linux kernel. Like, I've been doing this for 9 years. I need a change. I want something else, and then you start having other problems on top of that to compose over time. So I was looking for something else to do. What I really wanted to do was to start my own company. But then by the time I was ready to leave Scylla, that was 2020. And in 2020, if you remember, something happened, and like the world was very crazy. And then I just thought that maybe it wasn't the right time to start a company. I was wrong, by the way, because money was flowing freely in the startup market, and which is why I ended up staying only a year at Datadog.
Yeah, in hindsight, probably was flowing more freely back then than it is now, right?
It's very fascinating, but just it's the interest rates, I guess, because if the same phenomena that led you, like housing prices going up and etc. The VC community just had a lot of money floating around.
Yeah.
So in 2020, I decided to join Datadog. And in 2021, I think it became clear to me that, hey, if I want to start a company, I could. And I had the opportunity, and then Pekka was willing to do it. That was my one. That was the one thing I wanted to do to start a company. I said I will start a company, but I will only do this when Pekka is willing to do this with me.
Him
right?
specifically.
Specifically, I love
okay.
Pekka. And we have this thing that on Twitter we pretend that we hate each other, and it's a great engagement bait. So we're always fighting, and we're always like calling each other names. Our friendship is like that, by the way. Is not that we act like that just for Twitter. We are like that to each other. Like we act like we hate each other. But then what happens on Twitter is that like people don't know us, right? So they don't know the context. So like, why are those guys? So it's not that we are putting a persona or anything like that. It's quite the opposite. I mean, it feels like engagement bait, and it is. But and we
it's your banter.
We milk it a little bit, of course. But at the end of the day, we're just being ourselves. But I love him to dearly. He's probably one of my best friends, if not the best friend I have. I've been to his place in Finland a couple of times. He hasn't been here to the United States yet to visit me, but again, I'm new here. Hoping he can come. And I knew that if I ever started a company, I wanted to start a company with him. We had this list of ideas that, hey, one day, and were crazy ideas like a special mattresses that warm you up. These days you actually have one that cools you down, and just
Right.
the software and non-software. Like we had this bunch of
Okay.
ideas, what kind of things we could do. So we started a company in 2021. And it's funny because our story ended up being very similar to Scylla. We were not trying to do it. In fact, we were quite explicitly trying to do the opposite, right? Because we've seen all of the things. At Scylla, I was employee. I forgot to mention, but I was employee number 3 at Scylla,
Okay.
at the company doing the unikernel thing. And
Yeah.
Pekka was the employee number 4. Because when he saw that I joined, I said, "Hey, I want to join too."
Yeah.
And we always like to work together, like since the kernel. And then like he was looking for a job. He started working for the company. It was called Cloudy Systems at the time. So we both worked together at Scylla for like around. He had an extra year ahead of me. And then one day I said, "Hey, Pekka, let's just start a company." And at Scylla, because we were so early, we saw everything that they've done right. And we also saw everything that in our minds they've done wrong. So one of the things we want to do everything different. I mean, we'll try to keep the things that I think they've done right. But the things that we thought they've done wrong, we want to explicitly do it differently. And we did everything differently. And fate wanted it, so we will land about in the same place, right?
Be specific, though. What specifically did they do well and badly that you wanted to learn from?
Well, I think what they did very well was not trying to, for example, when pivoting the company to Scylla, they picked because writing a new database is a temptation, right? Oh, new database, and then you start thinking about all the things that you could fix in databases, and it's always like. This thing is not great. I'm going to do better. This thing is not great. I'm going to do better. But what I think that folks at Scylla understood very, very well is that something being bad doesn't mean it should be replaced, because some things acquire this giant inertia. And this is one thing that we're keeping, for example, on Turso. There are many embedded databases out there. So we'll talk about more later, but we're writing an embedded database that's fully compatible with SQLite. Scylla was a rewrite of Cassandra, of Apache Cassandra in C++ with a different architecture. There are many things wrong with Cassandra. The query language is not the best. Like that. I think there are many, many, many things in Cassandra that were bad. Some of them are fixable, and then you fix them. They're architectural, like that. They are in the way that the code is structured, in the way that the engine works. Some of them is things users interact with. Everything users interact with acquires a giant inertia. So there's and then you don't change them. So Scylla was a fully compatible rewrite of Cassandra. And sometimes we will look at it and say, hey, man, if this feature did not exist and nobody uses this thing anyway, we could make this other thing 10 times faster. It doesn't matter. It has to be there. It has to be, you can disable. There are ways in which you can do this. But it has to exist because drivers depend on it. There are integrations that might depend on it. And so understanding the power of the ecosystem was one thing that Scylla did very well. And we did the same. So we were like, okay, there are many people who try to write embedded databases. But we understood and we understand that it's not enough to be an embedded database. It has to be fully compatible with SQLite. So understanding the power of the ecosystem, I think, is something that they did very well. And it's something that we're replicating. So we're trying to emulate that. The other thing that, the thing that in our mind, they didn't do very well was validating more aggressively the market for the unikernel thing, and taking too long to pivot. So we wrote this unikernel for 2 years, and then it didn't work. And then we ended up writing Scylla for another 2 years. And by the time the company put something out there, it was a 4-year-old company almost, right? So we wanted to move a lot faster. We said, hey, look back, like we don't want to pivot. So we want to have the right idea right away, which is easier said than done. But if we have, so we're going to put a lot of effort into validating that this idea is actually something good. And if it doesn't work, then we have to pivot like way more aggressively. We have to move a lot faster. But the funny thing, I mean, fate is an interesting thing, is that we did all of that. We validated things. We spent almost 2 months just talking to people and understanding, is the thing that we're building the right thing, and it ended up not working anyway. and then we pivoted to, but we did pivot faster, and then we pivoted to a fork of SQLite, which we maintained for a little while, and then we built a cloud service on top of that.
Okay, hang on. I think we've jumped a step. So, what was the first thing you built?
I sometimes I just mentioned, because I never want to dwell too deeply on that, but it was called Chisel Strike. Chisel Strike was a edge system for data persistence. So our idea was like, hey, people don't want to write SQL, but SQL is pervasive anyway. So what we're going to do is that we're going to merge a database, SQLite, with a TypeScript runtime, Dino. So we had Dino with embedded SQLite in a way that you could deploy in the cloud, and a query compiler. So that would allow you to write your code in pure TypeScript. The compiler will automatically generate SQLite queries. So you would just write TypeScript code, and then you would mark some classes as persistent, and you would not be aware that there was a database there. Now, wasn't a great idea, and we in fact we learned a lot about the process of validation, because at the time it's, hey, let's do a lot of validation. But the way we did validation was just asking people if they would use it, and they all say yes. But then they never do.
That's the difficult thing. And then you go away for 2 years and build it and come back and they say, well, I didn't mean I'd use it for money.
Yeah, or like, sure, I would use it, but I don't feel like it right now. Or whatever. So it became clear to us after a year. But that the second part we did right. Like we said, if we need to move away from this, we're gonna do it super fast. So after a year, it became clear to us that this wasn't working. We were using SQLite. I love SQLite. SQLite was the first database that I used in 2003, something like that. I was mesmerized that the database was just there. The SQLite 3. There's a database here. There's no servers. There's no nothing. The database just works.
Just a standalone process that magically turns into a database.
And like I say SQLite is the most used database in the universe, not the planet, because as soon as it gets used in the Mars rover, it is the most used database in the universe.
Okay. I'll allow you solar system.
Well, fair enough.
Aliens must have a database. They must.
We don't know what they're doing. We don't know what the Pleiades or whatever people are doing. But in our solar system, for sure, it's maybe let's dare to say the galaxy. So it's in the galaxy, it's the most used database. And we were very fascinated with that. It started to become clear to us, though, the SQLite had a lot of limitations. Which I'll be happy to expand. But just to finish how do we get to Turso? Turso was an attempt that we had to build a fork of SQLite, in which we thought we're going to fix a lot of the problems with SQLite, and then we built a cloud service on top of that. And the idea is that you would use SQLite over the wire, and have replication and edge replication. Now, that Chisel Strike didn't work. Turso worked. Turso's there. Like we call it the Turso Cloud now, but it works just fine, right? But
do you mean as a technical project or as a business model?
Both.
Okay.
Yeah, but we knew that it started to become clear to us that, again, the analogy that I used when I published my first blog about what Turso is today, because Turso today is a rewrite of SQLite, a full rewrite of SQLite from scratch. And then what was Turso before? We renamed it to Turso Cloud. So it's good. We want to use like the same branding everywhere. Like Turso Cloud will be just a way for you to deploy today SQLite, in the future Turso databases to the cloud. But the analogy that I use is that, look, you probably heard that phrase, shoot for the stars. If you miss it, you're going to hit the moon, or you may hit the moon. I mean, it's not a guarantee, but we felt a little bit like that because when we started this fork of SQLite, we had this grand vision and this grand dreams and ideas, and now we fork SQLite, and this is going to happen, and that's going to happen, and that's going to happen, and none of those things did happen. So we were, a little bit sad, but we built a good business out of it, right? So
okay, you're going to have to take me through the motivation of this, because I look at SQLite and I see something that I don't see many problems with it, except maybe it's too small to run a large service on, but that's by design. And I believe it's multiple reader, single writer, which seems like a limitation.
That was one of the big limitations, yes.
What did you see when you looked at SQLite that you thought desperately needed fixing?
Yeah, so it's great to dwell on that because that didn't change from the Turso cloud to Turso today. The main motivation, like what is wrong with SQLite, didn't change in our view. What did change is that we thought we could fix this with a fork, and a fork took us up a certain point. And later when we tried the rewrite, and just to mention that when we announced the rewrite of SQLite, we had 9,000 GitHub stars in less than a month, and it wasn't working. Turso still doesn't work. Turso is alpha at the moment, right? But we had 9,000 GitHub stars in less than a month and 60 contributors in less than a month. People coming in and contributing.
So there's that much pent-up demand for a rewrite of SQLite. Why? That's right. What am I missing? What's not good enough?
I'm going to get there, but just this is for me, I think, so critical and crucial to understand, because what did not happen with our fork was exactly that, like this community embrace of people coming from all sorts of places with all sorts of different motivations and their own agendas. But now let me go to your question, which is like, what were the things that were wrong with SQLite? There is one thing, and the word is funny because like wrong is on the eye of the beholder. Like wrong, what does it mean to be wrong? I think sometimes we say that people understand that we are saying like they are objectively wrong. Look, some things are by design, some things are trade-offs, and so wrong. I admire their work a lot, and I always try to make it very clear.
Okay, but what different decisions would you make?
I think SQLite is the best database in the world, right? Even with the limitations. But the one thing that and a lot of startups, sometimes you hear this thing about, are you the right person in the right time, and etc. And I think this applies to us because the one thing that I think everything flows. I can spend hours for you telling like the things that we would wish SQLite would do better. Multi-writer and multi-writer is the thing that a lot of people ask for. But I think they all flow from one thing. They all flow from the fact the SQLite is and this is their wording, not mine. This is on the SQLite website. Open source, but not open contribution. And what it means is that you can see the source, you can download the source. The source is public domain. It doesn't even have a software license. But nobody contributes to SQLite, with some exceptions here and there. Right? SQLite is not an open contribution project. I think 2 or 3 people work on it. And they say very explicitly, if you want something changed, you're welcome to send us code. We will read your code. If we like it, we'll implement our own way. And most of the time, we're not going to like it. So it's a open source, but not open contribution project.
Right.
In my mind and in Pekka's mind, all the limitations and all the glass ceiling around SQLite comes from this fact, that you don't have a large community of contributors that are helping push this thing forward. And here's where I think the right person at the right time comes along. A lot of people think that the reason SQLite is so great, it is exactly because it's a single, let's say, a single individual, but 2 or 3 individuals. Because there's so much slop and there's so much, like you see a lot of those projects that go in crazy directions and you take contributions from everybody and then like it's the old argument, like what is best is a democracy or this or
benevolent kind of dictator for life.
Some systems are better for this or for that, and like again, then there's China. Software projects are completely different than political projects to begin with, but I think there's a lot of people today in our industry that see a lot of slop being generated, see a lot of open source software like moving at like being influenced by money in a not so healthy way, and etc. And they all see, like, we've heard this so many times, people arguing over this on Hacker News. The reason SQLite is great is because there are only a few people who contribute to this, because they can have this, gatekeeping. They don't need like people. Now,
Yeah.
Linux is the counterpoint,
Yeah,
right?
I can
So
totally see how you would come from that perspective that says, actually, this
exactly,
can work, right?
exactly. So
Yeah.
working with Linux for so long, as Pekka and I did, very closely to each other, we give the devil its due, because this thing that people say, that the slop takes over the project and the project starts becoming bloated, and it's the forces are there. Working in the Linux kernel, we admit that, like, it's the work of a Linux kernel maintainer is very part of the work of a Linux kernel maintainer. And by the way, maybe that's why I never became one, because I'm not very good at putting the brakes in that.
Right.
Pekka is fantastic at that. Is exactly working as a counter entropy, counter slop force. No, this is the quick way to get us there, but we need to do this the right way that get us there.
Yeah.
And the culture in the Linux kernel was very, very good at enforcing this. Now, in a very brutal way, as and I think the brutality becomes a part of, like, hey, how there are only so many ways in which I can tell somebody who's going to start arguing with me that forget about it, your code's not getting in, because then people start arguing and
Yeah.
etc.
Yeah, people take it very personally too, and that can be difficult.
People can take it very personally, and one of the ways is just saying, "Go away! I don't want to see you here anymore." Now, again, is it the best way? I don't know, but it's part of this enforcement culture in the Linux kernel. So we start by giving the devil its due. Yes, it's real. The forces that turn software into slop are very real, and we know them, and we dealt with them for 10 years. We understand that they exist.
And those forces have got a new ally with AI that's accelerating that side of the equation.
Yeah.
Right?
It's a brave new world out there, and I'm very curious to see how AI is being handled in the Linux kernel, because I'm sure people are sending AI work there. But
it's a multiplier for good things and bad, in my opinion.
Exactly,
I'll say that.
Yeah. For we use AI a lot in the company, right? But we knew like, hey, yes, you're right. The forces are real. There's this entropic tendency of turning anything into slop. But we also question this idea that it has to. The only way to do this is by having a community of 2 or 3 people. I mean, Linux was a community of thousands of people, and it works. It can work. And but the other thing we always question, but SQLite is designed for this. Therefore, this other thing doesn't fit here. Like you said yourself, I mean, it's not very good for big systems, but it's probably fine, because that's the trade-off. I mean, we question that, because in Linux, famously, you probably know, but maybe kids these days don't know, but Linus Torvalds, when he started Linux, he wrote this now very famous message to the Usenix mailing list, saying, this is just a toy, this is just a project that, it will never work. It will never work on anything other than x86 processors, and it will never be big as new, and this and that. And like, Linux started as something very niche, very small, very focused, and now it powers both the Mars rover and the biggest supercomputers in the world. So it is entirely possible. It is entirely possible to have a system that works great across the spectrum. It is entirely possible. And again, it's possible because you have different people with different agendas, with different motivations, that come together and find a compromise. That's what we wanted to recreate.
What I need to know is, are you saying there's a whole bunch of things that you wanted to change about SQLite and you thought you could build a community around it? Or are you saying if you opened up the community, things would happen? I mean,
it's a little bit
did
of
you have
both
an
because
agenda of
yeah,
features?
it is a little bit of both because we do have things that we would like to see on SQLite, but most importantly, we kept asking, we kept seeing in front of us very obviously that those things would have been fixed by now if only you had a larger community. So we do have things that we believe SQLite should do better. And again, we can come up with a list, and there is a big list, but I think the main one that everybody's been asking us for is concurrent writes, because SQLite doesn't do concurrent writes.
Yeah.
And it's funny because it's actually not the one that we wanted to do. The one we wanted to do at the time was just replication. We wanted to be able to replicate the SQLite wall, the write-ahead log, so we could write the distributed database. And we've seen other people doing it. And there was a project from Canonical called SQLite. And they wanted to do exactly what we wanted to do in our company. And they wrote the code, and the code was not very complicated. The code was actually fairly simple. But again, you cannot merge this code back to SQLite, right? So we start later, as we started running the cloud service, it became clear that the concurrent writes was the thing that the first ceiling that almost everybody hits on SQLite is concurrent writes.
Yeah, that makes sense.
So it was the one thing that I think I wanted to fix. Turso has support for CDC, which SQLite doesn't have, which is another change data capture. So you can have a stream of changes that happen to the database. It's a feature that almost every database has. And again,
that makes sense. If you're cracking open the write-ahead log, that wouldn't be too hard to add in.
Turso, the fork, it was not called Turso, it was called LeapSQL, the fork. And then Turso was the cloud service built on top of that. But like Turso, the database that we write now that we're doing has CDC. We want to add encryption. We already have a vector search because vector search is something that is becoming quite important today. So there are a lot of features that very specifically say, hey, SQLite could do this. If you go see from the community asks, what is the people using, for example, our cloud service asking for, CGC and concurrent writes, top two asks. But we had, I think, I always, and maybe we should talk more about features, but for me, it was always a social issue first and foremost. If you fix the community, if we fix the community, if we have an open contribution community, those problems that, things that we don't even see today as problems because it's not a use case that we care about, somebody will, and we're going to have there's this large amount of oxygen that comes into it, and how do you do? We're going to have to resist this law. We're going to have to do this, and etc. And that's where we fork SQLite. So these reasons didn't change. I mean, we decided to fork at the time instead of rewriting.
Makes sense.
And we had reasons that made sense at the time, and I think they were wrong, but not in hindsight. I mean, in hindsight, nothing like obviously wrong. We were just proven wrong. But we had this dream. I mean, we're going to make SQLite into this open contribution. We wrote a manifesto. We said, this is the open contribution fork of SQLite. Right. Come build with us. And very few people came. I mean, nobody came to the core. To the core, nobody came. A couple of people came around, again, in the margins, and we had a couple of contributions here and there. For the core, nobody came. And
I don't understand why a fork wouldn't get any attention, but a complete rewrite would.
I do understand now. Understand now. But again, I'm with you because that's why we decided to fork. Right? We decided we fork because then we're compatible from day one. It's working from day one. Right? There's nothing, just so we saw that the things that led the fork not to be. So I want to clarify here. We built a successful business on top of this. So when we use the word successful, I just want to be careful, right? Because our endeavor was successful, but the dream that we had. We're going to build this open community of contributors around SQLite, and people are going to start using our thing instead of SQLite everywhere. Those things did not happen, right? So it was that analogy of like shoot for. And look, we were happy with that.
Yeah. I mean, if you've got a startup that's paying the bills, that is quite a lot in itself, right?
That's right, and the just a quick context of how that came to be, because I mean it's not that we were actively thinking. It's different than when we pivoted the company, that we were thinking, oh man, this is not working, what do we do? For us, it's like, this is working great, right? Now we were aware of the limitations, and it was being very hard to fix them in the fork. But then Pekka decided to play. As I said, Turso today being in alpha was a full rewrite of SQLite. When we announced it in December, we announced it. It did not even support transactions. You couldn't write to the database. It only support part. It only supported part of the select statements. So you could read some data from the database. So again, it was really just a weekend pet project. Not a weekend, because he was working on it for a couple of months, but it was Pekka's pet project.
Yeah.
Right? But we started to see that, and to your point, I didn't quite understand why at first, that maybe this is what people want. And it does show to me, by the way, that the pent-up demand for SQLite is not only a technical pent-up demand. I mean, it is a sit on the table pent-up demand, because people came and flocked to it. And so Pekka started working on this more seriously. I mean, Pekka is always doing things like that, writing small toy systems to test hypotheses.
Yeah.
So he had some code of like, hey, how would a new bytecode interpreter that interpreted the two most used SQLite instructions would look like? Boom. So he had like a toy that he would do some prototypes on. He started working a bit more seriously in this project. I think it was around July of last year, something like that. So we did not. It wasn't a Turso project. It was not on our GitHub account. It was not anywhere. He then, in 6 months, we were not talking about it. So, I mean, we were not talking about it on Twitter. It was just Pekka pushing code to GitHub, just him. We had, like, that project had 1,000 GitHub stars. And just people finding, I mean, if it's not us talking about it, it's just people happening to find
organically
it on GitHub.
How
1,000 GitHub stars.
And why do they care? Why do they care more?
And here's the most important part, because remember the dream, building the open contribution version of SQLite. Pekka's little cute side project had 32 people contributing to it. Without anybody talking about it. And
he was merging their contributions.
That's right.
So the feedback loop has begun.
Yeah. And 2 of those people were so good, because, again, there is this thing about the power law, right? There are many, just like in the Linux kernel, there are many contributors doing easy things here and there. Some people become part of the core. 2 of those people were so good that we decided to hire them to work on Turso, the cloud. Right?
Yeah.
And so we thought, hey, Pekka, there's something here, man. There's something here. So what we decided to do in December, it was December the 16th, we decided to, nothing extra, no more code, nothing, like, just we're going to move this from your GitHub repository, just a transfer operation. Move this from your GitHub repository to the Turso GitHub repository, so there's a seal of approval, right? And we are going to write a blog post about it. That's it. It took us maybe 4 hours to do all of that. I wrote a blog post. In the blog post, we said, hey, this is what is happening. What is the announcement? Pekka's pet project is becoming an official Turso research project. What is the end goal of this? I do not know. It's just like hopefully over time, and I can give you the link later for you to put in the description, but hopefully over time, more people will come contribute to this. I don't know. And then we go out for holidays, right? When we come back in the beginning of January, from 1,000 stars, because when you move, we only transfer the repository, it keeps the stars. From 1,000, it jumped to 9,000 in the space of less than a month, quite honestly. And from 32 contributors, it jumped to 64 contributors. So it doubled in in around a month. And this was mind blowing to us. And now to finally answer your question, I started talking to those people.
Yeah.
Why are you here? Right? Some of those that we had hired already, and their answer, which is another hallmark of things that work, their answers were very consistent. Were they aware of our fork? Yes. But when you fork SQLite, you are beholden to the SQLite architecture. You don't have a blank canvas to create something anew. The fork was, most of the code of the fork was, because of the nature of being a fork, was in C, which is a language that is very hard for a lot of people today to consume. Now, those engineers that we were talking about, they're super good. They can consume C, but some of them is becoming a rarity, even across top-notch programmers. The rewrite was in Rust.
That's got to be very significant.
It is fairly significant. And now what I think is the most significant thing, even for us, like we built vector search into the fork. And it's just because it was a feature that a lot of people were demanding. And vector search is kind of easy to build on the margins, but we built it. But and again, not that we do not know this is a potential trade-off, but here's another thing that a lot of people do not know. A lot of people like SQLite because SQLite is the most reliable database in the planet, or at least the galaxy. And again, that is because their test suite is incredible. SQLite has 10 times more lines of code in the test suite than it has on the database itself. It is incredibly reliable. It's battle tested. Everybody loves that. But that test suite, lo and behold, is proprietary. You don't have access to that. The test suite itself is not open in any way. So it's not even downloadable. It's not even like the source is, you cannot run the SQLite test suite. So in the fork, to make more aggressive changes, it was very hard because you can't really test the changes. Now, you can test the changes because you're making the changes, but it's very hard to test the effect that the changes have on other parts of the system because you
can't run the whole test suite of existing stuff.
And we kind of brush it off over time, and we said, like, we'll figure this out as we go. We knew this was going to be a problem for the fork, but we said, hey, we're just going to have to write a bunch of tests, right? But over time, I mean, it was a very hard thing to do. So what we ended up doing instead is that even our contributions, they naturally became relegated to the margins. Now, with Turso, the rewrite, we use deterministic simulation testing from day one, because when you're writing something from scratch, you can write it in a way that lends itself to a very easy way of testing. I am sure you talked to Yoran in the past from TigerBeetle. We were very inspired by the work that he was doing at TigerBeetle with deterministic simulation testing. And we knew that we could use deterministic simulation testing to prove to ourselves and to the world that whatever we were writing had the same level of quality and reliability than SQLite.
So this is the thing where you kind of set up almost a virtual operating system for the test suite, where you can simulate the network failing or the disk failing.
Yeah.
Which makes sense given your background.
Yeah, it's not just failures. Deterministic simulation testing it's an interesting combination of fuzzing, property testing, and fault injection. I think the term is just used loosely, but if you talk to an expert, he will say, no, this is just fault injection, or no, this is just fuzzing, because you can have those things. You can do one without the other technically, but a good test harness that we have will do all of them. So what's going to happen is that you're going to randomly generate a large. You don't write unit tests like a select star from table. You write a query generator. You write the test generator, and then instead of testing, because you don't know in advance what the query is going to be, so instead of testing this query has to have this result, you encode properties of the system. So an example of a property, that one is very easy. An example of a property is very easy to understand, is that after you write a lot to the database cannot be corrupted. So if you write, and do a lot of random operations, and then you run an integrity check on the database file has to be sane and not corrupted.
Yeah.
So that is a property of the database, for example. But you have other properties, like you have to read what you wrote, or so you encode. You cannot like write the value and then in the same transaction read the value back and don't see what you wrote. So you encode all of those properties of the system, and then you let the simulator run or write with that. Just generate queries randomly. We do fault injection, so every now and then, with some probability, you inject a fault. The simulator, it's a page from disk that didn't return fully. It's something that failed, memory that blew up, allocation that failed. Something happens that is faulty, and the system has to behave well on top of that. And now the deterministic part is the most important, because you have to virtualize all of the I/O that you do. You have to virtualize all the operations that you do that interface with anything in the outside world, so that if you run the simulator again with the same seed, it generate the same result. Because now you let the simulator run for hours, and in the hours that it runs, it simulates like sometimes decades of real of complicated execution. And if it fails, it gives you a seed. And then if you run the simulator with that seed, it fails in the same way. So that's where the deterministic part comes from. Right?
So it looks like it's behaving randomly, but it's randomness based on a formula from a seed value.
Exactly.
So you can make the exact same kind of randomness.
So for example,
one
of the things that you virtualize is reading a timestamp, right? Because there are many bugs that will only show up. For example, you can have a bug that only manifests in the day of where the Unix. I forgot. There's a name for that. Like we had the year 2000 bug, and then there is a name that people use for the upcoming Unix pandemonium.
It's the end of the epoch, isn't it?
Yeah, because Unix uses 32-bit for timestamps, and it's coming to a close around 2030. So this is an example of a bug that only happens with some timestamps, right? You have things about also. So every time you do something that requires, that it's going to be different across executions, you do it through you do it through the simulator. You don't go and read the time from the operating system. You read the time from the simulator. The simulator will always give you the same time for the same execution, right? So you run this, you let the thing run completely awry, and then if it fails, it gives you the timestamp. Because of that, we released our alpha finally a couple of weeks ago. It's alpha. It's being developed by 6 months. If you don't count the 6 months prior, which was just Becca, and now like very actively, because we're not going to talk too much about it today, but we completely reoriented our company. The cloud business is there. It's on hold. It's on pause. We're not adding new features to the cloud. Our entire company now is working on rewriting SQLite, right? So it's been 6 months only that we've been developing this with full force. And if you go to turso.algora.io, you will see the Turso challenge. The Turso challenge is the following: if you find a bug that leads to a data corruption, and you show us in where the simulator missed it, because the simulator is just software, so the simulator has to explore the space of probabilities. And there are, of course, places that the simulator doesn't go yet. So we say, if you find a data corruption bug and if you show us why the simulator missed this, for example, maybe you were never mixing indexes with views, right? And then you missed this one bug here that led to a data corruption.
Yeah.
Or like the fault injection for reading from disk was not random enough, and so there was this one. So you do that, we're going to pay you $1,000.
Okay, so you got a bug bounty on data corruption.
Yes, and again, some people, of course, because there's always some people. The internet is my favorite place in the world. You must not be that confident then if you're only paying us $1,000, right? And obviously, the people who said that didn't contribute anything and didn't find anything. But it's also a fair criticism. But it's alpha. It's there for 6 months, right? Our plan, and we say this very explicitly in the challenge, our plan is to increase the bounty. So for the beta that is coming in a month, I want to increase that to $5,000. Later, maybe next year, we want to get this to $10,000. And over time, we want to increase the bounty. And we
That makes
also want to
sense.
increase the scope of the bugs. It's not going to be just data corruption. It's going to be, for example, ACID violations, right? Over time, we want to be confident. And we say Turso is not ready for production. It's alpha software. They're not running in production. But we're confident enough that if you find the data corruption, we're willing to pay you because we know they're very little.
Let me nitpick there. Surely violating ACID constraints counts as data corruption.
No. Data corruption is a very well-defined thing. Data corruption is the database losing or corrupting your data in a way that is not recoverable by a future patch. So if you have an ACID, now you're right that there are some classes of ACID violation that can lead to data corruption. For example, if you write a value and don't read it back because the database lost it, there is a data corruption. But a situation where you wrote a value and then you have a problem reading the value, but the value is there and is recoverable, is not a data corruption, right? Because you can patch the database and retrieve your data.
Okay. Yeah, I kind of see what you're saying. Yeah.
Yeah. The data corruption is like I was supposed to write this value and we just didn't. There is no way to recover this. Your data is gone.
So you're saying if it's somewhere in the write-ahead log, for instance, then that counts as not right. Okay.
Or it doesn't have to be on the write-ahead log. It can be on the main database file. But you can be like, I was supposed to write the value 4. Then there was a problem with the serializer because the serializer depended on reading a timestamp or something like that. And instead of 4, I wrote 40. Okay. You are never getting your 4 back because you don't know what was supposed to be there. So that's a data corruption.
So how much of this, in 6 months, how much of it SQLite can you rewrite? What's the current feature set? Because it sounds like you forked a very large project.
Of SQLite now. We implement 70% of SQLite. Yeah.
What does that mean? Is it a project where 80% is under the surface and actually the last 20 is features?
In all fairness, the other it's one of those cases in which the other 20% is going to take 80% of the time, right? But it's still, I think, it's still quite impressive. And one of the things, and some contributors, because we have now, as of today, 137 contributors to Turso.
Right.
So remember, it started with 30 before, which was just like some random people, 2 very good. In a month, it was 64. Some of those, out of those new 32 that came in, some of them are still with us, right? So some of them came and stayed, which is what you want to see in a healthy open source community like that.
Yeah.
We already have people who found jobs because of their contributions to Turso, which is another great sign.
That's
another great sign. We have people who use Turso in their PhD thesis. Another great sign, because you start having those people who have different agendas and different motivations. We wanted to recreate the Linux community without the screaming. That's essentially our with SQLite, because SQLite lacked that, and this is happening. This makes us so happy. But you talk to some of those early people, and what they say is that one of the things that made it easier for me to contribute is that when Pekka started the project, and this is his merit, one of the things that he did is that he wrote a file called compat.md, is a markdown file, with the entire compatibility matrix of SQLite, every single pragma, every single part of the expressions, like the selects, inserts, it's called the AST, right, the abstract syntax tree. Every single bytecode instruction is listed on that file. And then there is what it is. First of all, there's categories, bytecode, pragmas, functions, expressions. What is the expression or what is the thing? Status, comments. And then in the beginning, it was all like status. No. And now, if you count the number of things that are marked as yes, that's 70 to 80% of SQLite.
That's where you're getting your figure.
Yeah.
What does that mean for me, though? If I go and download Turso and I am used to SQLite, what am I seeing? What makes it alpha? What am I missing?
So what makes it alpha is, first of all, that we do believe that it needs more time. The alpha did not support indexes. So one of the things that we believe that for this to be ready, is that we need indexes working, and we need some other features. I think the main features that we're missing now are material. They're views, triggers, and vacuum, right? So those
Right.
are a couple of things that they're missing. We're going to go into beta with that. The main reason I think we have this as alpha is that, again, as I said, the simulator is great. The simulator helps us find all sorts of things, but we know that our simulator is not perfect. So we know that there will be some problems that are there. The simulator just hasn't found it yet. And so we believe that, in the spirit of we're not going to put slop out there, it's just time. Part of it is like it needs time. But we are confident that we can actually get to the point in which you say, hey, this is production ready within the year. So if you count from December to December, we think we're going to have the rewrite of SQLite, missing a couple of things here and there, but mostly usable by most people within the year.
Okay.
There are two ways to consume Turso. One of them is through the embedded drivers, just like SQLite. You're using your programming language of choice, Rust, Go, TypeScript, Python. Python is one of the communities that are embracing Turso the most, as we see from the statistics on downloads, right? So you go on our TypeScript, you do like npm install Turso. You're going to have a Turso driver, and then you can create a database, do selects on a file, all of that. SQLite is that, and SQLite also comes with a shell, which is how a lot of people interact with SQLite.
Yeah.
Turso also has the Turso shell. So you download Turso, you point to a SQLite file or to an in-memory file or to a new file, and then you can use it. You're going to see a message saying this is alpha software, but by and large, it's there.
And let me just clarify, because it seems like indexes, that's a big missing feature. You think they'll be in by the end?
Anymore, but it was missing from the alpha.
So it's going to go into the beta?
It's already done. Yeah, it was. Yeah.
Okay.
But by the time we released the alpha, we had indexes already. They were just full of problems, and we decided our goal is to go straight to beta, but indexes were still one of the features that were problematic the most. So we said, let's disable and make it alpha, which we don't regret, because there is also this component of, yes, we trust the simulator, but it needs time. Right? There's some level of trust that only will come with time.
Yeah, that makes sense. You've got to bed that in. But okay, so the current status, what you think you have is something that's very close to the present state of SQLite, but needs time to prove itself. Is that what you're saying?
It's one way to look into that. But, and if we're going to be precise, first of all, it already has things the SQLite doesn't have. So examples, vector search and CGC. So the main features that we have already that we're going to be in the beta, the SQLite doesn't have. Vector search, so you can do vector search on Turso. CGC, so you can see the stream of changes. So Turso automatically will keep a table with the changes made to your tables with index. So you can consume the changes since the last time you look into the stream of changes.
Okay, so you can do like a real-time stream of what's new.
Yeah.
That's nice.
More or less, yeah. So you see, like it's mapped as, because of the SQLite is not a server, right? That you can just put a listener process. It is mapped as a SQLite table, and you have to go and read it, but it gives you an index since the last read. So you say, let me read what's in this table, and then you know what the index in this table is. Next time you read from that index, and then you see only the changes from the last time you read. So there's some, because of the nature of SQLite, it's a little bit different than a CGC on a server-based database, but it's there.
Out of curiosity, is that transactional? Yeah. Can I say, okay, yes, I will commit how far I've read through?
Yeah, it's all transactional.
Yeah, okay.
Yeah, it's all transactional. We're also already have it in the beta. The ability, it's already there. The ability to run this in the browser, because SQLite some people manage to run this in the browser, but it's very hard because the browser is an asynchronous environment, and SQLite is fully synchronous. The one thing that we changed from the beginning is that Turso is a asynchronous process, so we can run in all of those complex environments, including the browser. So Turso runs natively in the browser. And because of the wall changes that we made, again, we made them in the fork, but we're bringing them in slowly to Turso. You can add a foreign page from a different wall into your wall. So what happens is that you can now do syncing. So you can have a database that gets synced to a cloud-based database, which is the nature of our business, right? But in Turso is even more powerful because you don't even need the server. I mean, the server will obviously help, but you can manually extract the stream of changes from one database and copy and push it to another database manually. And then you see essentially those databases syncing between each other in the browser. So we have that already in Turso. So Turso already does some things that SQLite doesn't do, right? And I think this is important to mention because it's not just a subset; it's more of a disjoint set at the moment, right? Turso will become a superset of what SQLite is, but because there are things of SQLite that we don't implement yet, you have this disjoint set in which SQLite has some things that we don't do. Turso has some things that SQLite doesn't do, but our plan by the end of the year is to turn that into a superset. We will do everything that SQLite does, plus extra features and time and the simulator and the reliability.
So let me see if I can guess how some of this works. If you've cracked open the write-ahead log, it becomes a lot easier to bring other systems' new changes in.
Yeah, the changes, the way the changes work today is that it uses a combination of the write-ahead log and the CGC table. So it's already happening that we built a feature and then we built another feature on top of the initial feature that we built, which is another great sign of a healthy collection of abstractions and in an open source project. Because what the CGC table allows you to do is have a logical collection of changes that you can use to do conflict resolution. Because imagine you are writing to a database here, and then you're now importing the wall from another database.
Yeah.
So what you do is that you import the wall, but if there are conflicts, you can use the CGC table to essentially resolve those conflicts. So you use those two things together, like the ability to ingest a foreign wall and the CGC table to have a syncing mechanism that syncs this straight into your browser. Not only in the browser, but the browser is one of the environments that a lot of people want to see this right now.
Do you end up in that situation with some kind of merge conflict process, or are you just saying timestamps and last writer wins?
Yes, and again, what you have now in Turso is very simple. Over time, you want to be more complex. What you have today is essentially that if you can't merge, you can't merge. Like if those two things if you wrote to different rows, if you wrote to different columns, it's fine. You can merge those. If you wrote to the same thing, you just error out and you cannot import that new information. But over time, you can. Our vision is that you're going to be able to specify conflict resolution strategies. Last writer wins, and this and that, or just like call a function that you provide to how do you deal with those things. We are working. So we have all of those features. We are working now in incremental computation for views. Which is a very interesting feature. So the idea there is that if you have a view, like our materialized view, that usually databases have to recompute when something changes on the base table, you have to recompute the view.
Yes.
More recently, maybe a couple of years from now, there is new research in the industry in something called incremental view management, and I think DMs for management. I might be mistaken on that, but the incremental view management is something that pairs views with streaming systems like Kafka, Redpanda, and others, so that to recompute a view, you only need to look at the new changes. You don't have to look at the whole history of changes. So incrementing a view becomes incredibly efficient, and you can have real-time querying on streams. So this is something that we're adding to Turso as well. Work has already started on encryption. So we're not taking the approach that first we have to achieve feature parity of SQLite, and then we go into new features. We're kind of doing this in parallel. We're doing this like in the sense that, hey, this is a good feature to have. Let's do it, right? And over time, I think naturally, and I think by the end of this year, beginning of next year, we will have a superset. But we're working on features that we believe make sense. Some of those features SQLite has, some of those features SQLite doesn't have. The majority of them SQLite have, like indexes. But we're peppering already from the beginning things that are, and the most important feature in the beta will be concurrent writes,
I was going to get to that.
which is the thing that everybody wants, right?
Now, how hard was that to add in? Because that does seem like something you've got to architect from the very beginning.
First of all, it's still being added. It's in the process, and it's very hard. It's one of the hardest things to do in the current batch of features that we're doing. It's one of the most. Pekka is working on it himself. It's just.
How are you that confident then that you'll get it done in what looks like 4 months to me?
Because I know Pekka for 15 years. And it might not be done in the sense that the feature is like fully done, and we might release it saying this is experimental. That would be something, right? The beta will not yet be production ready. I mean, still a beta. So we also have this. First of all, as I said, I know Pekka for a long time, and I know what he's capable of. It's also not in the early days, so I'm saying it's in development. It's hard, but it's more towards done than not done. And also we have the flexibility of the beta, right? It doesn't have to be rock solid for us to release it. We'll still release the beta with the warning that the software is now ready for production. And we also have and I think most importantly, because you have the simulator, right? The simulator is catching a lot of those bugs now. Concurrent writes is one of those things in which you have to improve the simulator to catch it, because the simulator that we have now doesn't generate writes concurrently because SQLite doesn't support it, right? So now it's one example in which, so you support concurrent writes. Now you have to improve the simulator to generate those combinations that were not there before. So there will be bugs, there will be issues, but I think it will be good enough for people to try in non-production systems.
Do you not run into the problem that the simulator has to be almost an operating system?
Yes, which is why we use two simulators. One of them is our simulator that we wrote, and the other one is a tool called Antithesis. Antithesis, essentially what they did, and it's fantastic. They wrote a hypervisor, which is essentially I love that because it aligns with my background so well. But a hypervisor is essentially like a virtual machine manager that runs operating systems on top of it and virtualizes the hardware, virtualizes all the abstractions that the operating system needs. So Antithesis built a deterministic hypervisor so that if you run the process in this hypervisor 2 times, the results are always going to be the same, right? So every time because of that,
a seedable operating system,
pretty much, and it's
testing,
one of the most interesting companies I think in the industry today.
What they do put a bookmark into that, because I'm actually recording a podcast with Antithesis tomorrow.
Will?
With Will.
Well, sending my best, and you can freely say that I said openly that his company is one of the most interesting companies. And the only reason I can't say the most interesting company is because there's our company.
Oh, of course.
And there's also TigerBeetle, which I think it's fantastic as well. But those are all my favorite companies in terms of the amount of engineering that goes into those things. But Antithesis is great. It's fantastic. It's amazing. And what we do is that we run ours. The way I like to explain that is that our simulator plays the role of unit tests in a project. You write some code, you run the simulator with the difference that this is going to run we run it for 4 hours every day. And it's very fast. I mean, you change something, you run that, in 4 hours you run 10 years of simulations, and the iterations are very fast. But it's very focused, and you have to write the simulator itself. Antithesis plays the role of integration tests. So it's something that you run. So what we do is that once a week, then we run Antithesis for something like a week. I don't know the exact number, but it runs for a lot longer. It doesn't depend on us writing the integration tests. So it's like the unit tests in this analogy, and it finds bugs even in our simulator. So it's those 2 layers of simulation. So first we run our simulator. And then once a week, with the code that was recently merged, you run the antithesis batch of testing, and then whatever escapes our simulator, antithesis usually finds. But you still need the workloads. I mean, you still need to, like, so for example, generating workloads with concurrent writes is an example of something that needs to be done for antithesis, and it needs to be done for our simulator, because otherwise the system will not generate them. It's just not part of what the system specification does.
How much, because this seems huge, right? It almost seems like you're saying we're building 1.5 operating systems plus a database from scratch. How much of this is being done? System, right? Sorry?
Yeah. But it's a simple operation. Yeah.
There are only few people in the world that can say it's just a simple operating system. Right.
Well, I mean, you can always say that in comparison, right? Just I don't mean to say that it's easy. I mean, in terms of scope and size, you've compared this with Linux. It's a simple one. It's small, and the surface area is small. It doesn't take that much time to
okay, but how much of this is happening in-house versus the community that you're building?
So today, like, obviously the main contributors to Turso, just by virtue of, like, we have. So I'm a firm believer, and our dream, as I said, is to recreate the Linux community minus the brutality, and I think we're on track to do this. And one of the things that I always understood is, for you to have a healthy community that is self-sustainable, you have to have people with different motivations that come to your community. That has to happen. And again, Linux famously had many businesses. Some of them, like Red Hat, selling Linux directly. Some of them, like Google, who are not reselling Linux, but they just need Linux to work really well on their hardware to run their system, right? So you started, or IBM, which was selling hardware, and then they know people are going to run Linux on this hardware, so they want to make sure that the Linux run. Those are the companies. IBM is not even that big of a name anymore, but those are the companies we remember were in the early days of Linux, like IBM, Google, Red Hat, Novel, and so this is starting to happen. So most people that we have today contributing to Turso are obviously our employees and people who work with us. Now,
right.
We also hired some of them. So when we saw, like, more of those people distinguishing themselves, and it's in our best interest to get this done sooner rather than later. Say, hey, look, we have an open position, we have the budget, you want to come work with us, that's fine. And in fact, there's this amazing story of this person who is currently incarcerated. He's not an prisoner. He is in prison, and he is now our employee. We hired him. It's one of the most. I'm giving interviews about this left and right. I'll point the interested parties at those interviews, so we don't spend too much time on that. But fascinating. But one of the contributors, there are two contributors, and I want to, of course, be fair to all the others, which are very welcome, and we love them dearly. So we have a lot of people who are coming, and they're coming back. And they keep contributing, but there are two that I will highlight only because I'm speaking about this narrow view of, like, hey, for this community to be self-sustainable, this needs to be, like, it needs to have this thing about I'm deriving value from this project, real value.
Yeah.
One of them is a Turkish man. We call him the Turkish Delight because he's a very sweet guy. Alp. Alp is a researcher. He's a Turkish guy, but he is a researcher in the University of Maryland in the United States. And his research is in deterministic simulation testing. So when he saw Turso, so look, this is my research. He poured a tremendous amount of work in making our simulator better. Because, again, he is using that in his PhD thesis, so he has the self-interest in doing that.
Right.
And the other contributor is a Indian man by the name of Krishna, and Krishna just recently found a job, largely due to his contributions to Turso. This is, he telling me not just me making this up. I mean, he told me, like, it's mostly because of the work I've been doing in Turso. And it's very likely that in his new job, they will use Turso as part of the solution, in which case he can keep working on that as part of his main job.
Okay.
So this is the status of our community today. I mean, 6 months in, I think it's a pretty good result. But Linux, of course, got to the point of being Linux after many years.
I'm certain it didn't get to that point within 6 months, right?
Yeah, this is, yeah. I am contributor number, if you go to to GitHub. GitHub shows you a graph of like the top contributors. GitHub is amazing because it has all of those informations. I think I'm number 14 or something like that. I'm not even in the top. First of all, because I'm managing the company, I don't have that much time. But I still write it because it's fun and it's nice, and I want to help the team. But there are 14 people ahead of me, and my company doesn't have 14 people. We have 10 people at the moment, right? So those others are other people who come through their own agendas, essentially.
Okay, so let's pull out and look at where you think it's going to be like a year from now, right? Presumably, you think you'll have got. I assume you'll have got to your first released version.
Oh yeah. The first release, that will be not beta off, etc. Now I want to do it December because then it will be like the anniversary is
The 12
significant.
months,
The same day Packer thinks it's crazy and it's not going to happen. It's just, but if it doesn't happen in December, then it's going to be early next year, like January, February, something like that.
But where do you think it's going to be positioned against? It seems to me there are 3 players in this market. There's SQLite established. There's you going for the new SQLite. And there's also DuckDB, which you must have considered as production ready, but analytics only.
Yes. So I love DuckDB. In fact, the CEO of Mother Duck is one of the investors in our company.
Oh, really?
And I wish them all the best. I wish them a lot of success. And I think what they're doing is fantastic. I have the thesis though. And again, you don't change the past, and things happen the way they happen. And this thesis is unfalsifiable and unprovable because I'll never be able to prove it. But here you go. I believe that if SQLite had an open contribution model, DuckDB would not exist because their first intuition would have been, let's extend SQLite to be able to run analytical queries. When you look at Postgres, for example, Postgres has a large number of extensions that change Postgres into a time series database, which is one of the keys to the success of Postgres, by the way. You can run Postgres as an analytical database. You can run Postgres as a time series database with extensions. And those extensions come. Now, there are many ways to extend the database. You can extend the database by making the database natively be able to do analytics, or you can have a very robust extension system, which is what Postgres does. But one way or another, you create this large ecosystem. SQLite has neither. Right? It doesn't have a extension system. It has one extension system, but it's very hard. It doesn't allow you to register indexes. It doesn't allow you to register new types. It doesn't allow you to do, and you have to write the extensions in C. It doesn't have any isolation. So if you write an extension that's bad, it's going to crash the whole thing.
Yeah.
Right. So there are many ways to extend a database. It doesn't have to be just make the database natively do this. It can be, here's an extension system. We might go one way or another. We want, of course, Turso to be extensible. But my thesis is that if SQLite had a way to be extended, either through contributions to the code base in a healthy community or a very robust and reliable extension system, DuckDB will not even have existed. You just go in, just like Postgres, like people are turning Postgres into those kinds of databases.
Yeah.
Right. So and now that they exist and they're great, they have huge momentum. It's fine. I think they will. It reduces our motivation to do any analytical work in SQLite because DuckDB on Turso more specifically, because DuckDB is there. But I think they would not have existed in the world in which SQLite was open contribution.
So you're saying that even though you're not going to go after that now, you can see a future in which Turso, maybe contributors to Turso, try and make it more DuckDB-ish?
I don't necessarily see a future because the future depends on the past, right? And we live in a world in which DuckDB already happened. So there might, like, why would somebody contribute? This is a large piece of work. It's not a weekend project to turn SQLite into one. So for somebody to do this, they have to have the motivation, they have to have the vision, and they have to be solving a real problem for a real business. And therefore, you do this. And because DuckDB exists, your motivation to do this is a lot less, and we might never see this contribution coming in. But it becomes part of the realm of logical possibilities.
Right. Okay. Yeah. Okay, let me throw in this feature then, which isn't a direct competitor to anything. But if I were to look at something like Turso, something like SQLite, I can see I would want vector indexes these days. The other kind of index I'd want to add is geospatial.
That's
and
right.
if I came along and said, hey, I want geospatial indexes in Turso, what would that look like today? And what do you hope it will look like 2 years from now?
Yeah. So first of all, great example, because geospatial is also a feature that we hear a lot in our community. We don't have anybody that we know that is very actionable within our partners, because we do have partners that work with us, say, hey, and that's why, by the way, we don't do the strict subset of SQLite, get your compatibility and then more features, because we have people who are interested in running Turso in production as soon as possible, and they want this joint set. I want SQLite with this. Okay, but do you use triggers? No, I don't. So no, we're not going to do triggers. We're gonna. It's healthier to get those people to production faster, right? Because then you have real people using this database in real life. And if we don't do anything the SQLite doesn't do, then they're just going to keep using SQLite. It's just right. But they want SQLite to do more, and that's the more that we're adding. But we don't have any of those big partners that want geospatial features, but we have a lot of people over the years that came to the Turso cloud asking for geospatial capabilities. The SQLite has an extension called SpatialLite to do spatial, essentially geospatial data. It is a terrible extension. And I say that I have never used this extension, and I can say it's terrible because I tried to use it and I couldn't. Because it didn't even. The extension is not actively maintained. It doesn't even. You have to compile it from sources. I tried a couple of times and I failed. I think, let alone a random person, it will be even harder. Even if I were to compile, because I found some binaries here and there, like it was like 30 megabyte binaries that you're not just gonna add to the core of the database. So I think I would love to see somebody, if somebody wants to get on our good side in our community, geospatial, come up with a geospatial extension. I would love to see a geospatial extension done right, integrated with the database, exposing geospatial types. I think it's going to be it's not a weekend project, but I think for somebody who wants to do this, it will be a very, very nice project to do. And what would happen is that it would still be something that is optional. So it's right now we still do extensions in a very similar way to SQLite, because again, we did not have time to extend how that works. But we don't do loadable extensions. So what happens is that the extension lives in the source tree of Turso, and you can disable and enable when you create the database, right? But that's it. So we would love to see this done this way. I mean, you contribute the geospatial code to our repository, and Turso databases now can do geospatial data.
Is it something? I mean, is there support for different? There must be support for more than one kind of index, right? Because you've already got vector indexes.
Well, so this is where this is one of the reasons a geospatial index will not be a weekend project, because conceivably it could be if we were much further along on the road. Vector indexes was one of the things that led Pekka to experiment with the rewrite, which again, as we said, was very successful, because adding the vector indexes to our fork of SQLite was very, 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 very hard. And then what we ended up having to do is that we have to, when you query vectors on our fork, you query them naturally, which is what we wanted to do. You can write a query in which you mix and match normal columns with vector columns, and then you use normal SQLite syntax to limit 10, and then you only see the 10 top results, right? And then you put a where clause. You first to filter by date, which is a normal column, and then you only search the vectors that were in that date. So it becomes a part of the language. But with indexes, it's not really. With indexes, you have to query an auxiliary table, and then you join. The index is a separate table. Then you have to join with the normal table. It's very cumbersome. And we did that exactly because by adding the ability of having just transparent types of index, it was a very core change. It was very hard to do.
Yeah.
So it's one of the things that and our vector search in Turso doesn't support indexes that well yet. To just have the brute force search, which is good for small data sets. Right, but we don't do vector indexes yet, and when we do,
okay.
After we do it, then making a geospatial extension will become easier because it will already have some kind of support for. Now the second it's still harder than the third because on the second, the first implementation will still have a lot of kinks for that you didn't even notice, but they become just the way vector indexes work and they're not that general. But then the second generalizes the implementation, and then the third and the fourth, and then it becomes trivial to add a new index.
Yeah. Adding index type number 2 is always going to be harder than 3 to infinity.
It's just like having kids. I just had a month and a half ago. We had our fourth kid, so having the first kid is very hard. Having the second kid is still quite. I mean, you have some experience, but it's still harder. The fourth kid is like, yeah, whatever, man. Just it's one more baby. No,
I reckon that the moment they outnumber the parents,
but what happens now is that my oldest kid helps out with the youngest, right? So it's you start to have this power, like there is power in numbers, and the example, the way it translates to the index example is that it generalizes better and better. So adding a new index will just become calling a function with some definition, right? Just at some point.
Okay, I again see a parallel between your desire to build large communities. It sounds like you're doing the hard way there.
Yeah, I'm doing the SQLite way, the serial, essentially single writer. Elon Musk is doing the concurrent writer way, so we're both trying to repopulate the planet.
Yeah. Okay, quickly pulling away from that difficult topic. So let me ask you another competitor question, because it seems like you're already kind of nailing SQL. You're already going after SQLite in the small, SQLite in the browser, the embedded story. But are you also, with concurrent writes, trying to get into a larger canvas? Do you think one day you'll be competing with Postgres?
To some extent, and in the same way that Postgres computes with MySQL, because they're both a database, and both of those systems, they at the same time compete, and then we don't, because they end up being good, and this is just the nature of how things evolve. They end up being good at different things. So when you look at Postgres, they look at MySQL, they have a large community of followers on both sides. And the Postgres people say MySQL sucks, and the MySQL people say Postgres sucks. And when you go look at those people, they're both right. It just so happens that they have very different workloads that they used to do. They have very different things. That it's all a database, but they're things, right? Just in the early days of, and you can have one of them grabbing all the momentum. But if you look at the early days of Linux, for example, a lot of the early routers and things like that would run FreeBSD because a lot of people just thought that it was better. And in all fairness, like it was. I mean, the FreeBSD network stack was much better than the Linux network stack for a certain period of time. Linux got a huge community, and at some point you cannot beat that momentum. And with that momentum, you end up becoming better in many things, right? And I think the Postgres community has that over MySQL. MySQL doesn't have such large community. Postgres. So if I were to bet between those two, looking 10 years in the future, I would bet on Postgres just eating MySQL completely. But in this point in time, there are certain classes of problems that MySQL is just better at. There are certain classes of problems that Postgres seems to be better at. Both of those databases do compete with SQLite because a lot of people use SQLite for normal web workloads. This is why, by the way, we came up with the idea of Turso. Which is now the Turso Cloud, right? The Turso Cloud, back then just named Turso, was a way for you to run SQLite for web server workloads. So you are on Cloudflare Workers, you call into our server, and then you use SQLite. So there are many people who reach out to SQLite for that, and SQLite beats everybody else out of the water in terms of simplicity. The problem with the problem with SQLite is now the default database in, as far as I know, in the Laravel framework and in the Ruby on Rails framework. So it is a database that is fairly used in the web. The problem with SQLite is that it's a great database to get started, but people who get started with it already know that the day they scale, they're going to have to replace this component. It's just a problem for my future self. So some people don't even start with SQLite because they know they're going to have to replace it. Some people start with SQLite knowing that they're going to have to replace it. Our goal is to get this I have to replace it out of the equation. Like, my SQL and Postgres will keep being better. There is a world in here in which you can imagine MySQL, Postgres, and SQLite, Turso more specifically, all fighting for parts of the server web market, and they will naturally become better and specialize in certain kinds of workloads. So this is it's a possible world. It's also, fairness, possible that Postgres just eats the whole thing. I think it's almost impossible that MySQL eats the whole thing, but it might be possible for Postgres. And again, because of the size of the community. But I think there's a lot of server workloads that we're going to do very well.
Yeah. At some point, it becomes less about the technical details of the database and more about the design space you're trying to go after. Right? What kind of things for what kinds of use cases that you want to do really, really well?
Exactly. Yeah. Exactly. Okay. And then again, and this is just natural. I think the way things evolve. Once more, the example I like, it might not be an example that resonates with an audience younger than 35, but the Linux and FreeBSD, and when I started using Linux, there was Linux, FreeBSD, NetBSD, and obviously the proprietary Unisys, and they all had their niches, and if it wasn't for the fact that Linux had this tremendously big community, this will be the situation that we're still at today. They all have those niches that they specialize in. Again, what happened with Linux is that you cannot compete with a community that has 10,000 active contributors. You just can't. You just give enough time, and this will become better than anything else.
Yeah. Okay. Clearly, that's your central thesis for the whole project. So let me ask you the last big question about community then. How are you going to stop it from becoming somewhat toxic?
The same way the Linux became toxic. So it's all about the role model, right? So Linux is toxic because Linus Torvalds is toxic. I mean, there's a lot of people who are not, but like what you clearly see is that those people see success breeds copy, right? Then people see Linus, they see that the way he handles the community, they see that it's working very well. Naturally, they want to emulate that. And I think the way you do this without becoming toxic, it's the same way. People will emulate Pekka. And Pekka, I think, is a person that more people should emulate in general, right? So it's the role of the leader. It's just I think Turso is under very good leadership, and that's how you avoid this. And again, the people who get quote unquote promoted to maintainership, like a lot of the role of the leader is the example, but it's also in picking the people, right? Okay, so you're now going to be one of the people who are selected to be one of the maintainers of this thing. You have to be a good role. You have to have certain characteristics, right? You have to act a certain way. So it's just leadership. Is the way leadership works.
You're making me think of our very first guest, Louis Pilfold, who I'm sure has said to me in the past, show me the CEO and I'll show you the company. And he does a very good job of leading by example. And well, in that case, I'll have to wish you both luck in that your growing Rust community and your growing SQLite competitor not only becomes a good set of features, but a good community to be in.
There's nothing we want more than that. And again, our community is a very intentional endeavor. It is not a second thought. We think a lot of it is true that a lot of open source projects these days, especially coming from companies, they're just a growth hack for the company to grow faster, or to get people at ease that if the company falls, you can have your data, yada, yada, yada. For us, it was never about that. I mean, for us, it's really us trying to recreate the good parts of what we saw in the Linux community. SQLite was the perfect match for that because it had no developer community, and we tried to do it once. Didn't have it succeeded in some things, but didn't succeed in the community building. The rewrite is just going fantastically. I think that we keep another reason, by the way, that I want to mention that is becoming. This one is interesting because it becomes less relevant over time. But one of the reasons a lot of people came to Turso in the beginning is that they said, I don't know if you can hear my baby or not.
I can hear part of your community in the background
Yeah,
calling for a tech support.
just great timing because we had a lot of people saying, I wanted to learn databases and I wanted to contribute to a database, and Turso is just so early that I could contribute. I could essentially come and write the query planner of a working real life database. Now, this reason, I think it becomes less relevant over time because now Turso is getting readier and readier. But we still have people showing up almost every day. We still have people that come with small features, and some of those features grow over time. They keep contributing. Some of them come and go away. That's normal too. It's a power law. Most things in the world end up being a power law.
Yeah.
And we're so excited to see the growth of the community. We run an interview on our blog with our community contributor number 128. It's the power of two.
Good choice.
It's a beautiful number. I want to run another one with our contributor 256, and we think it's going to be sooner. It might be sooner than we realize.
Well, I hope it keeps accelerating. Glauber, thank you very much for taking me through it, and I'll leave you to go for the more important tech support call.
There you go. I will.
Cheers. Bye for now. Thank you, Glauber. As I said at the start, Turso is now in beta, so do give it a try. And if you do give it a try, do send them some feedback. Links in the show notes as always. Before you go, if you've enjoyed this episode, please do take a moment to like it, rate it, share it with a friend, share it on social media, and make sure you're subscribed because we'll be back soon with another database episode of a very different kind, I believe. Until then, I've been your host, Chris Jenkins. This has been Developer Voices with Glauber Costa. Thanks for listening.